Assalamu alaikum warahmatullahi wabarakatuh. Okay, students, today we'll study chapter 3 of engineering design. The chapter name is Abstraction and Modeling. In this chapter, we have one problem with solution. So in final exam, you will get sure problematic question. So you have to solve that. You will get almost 5 to 6 marks. Now let's start. So the page number in the book of engineering design is 260 or 230. You can check it. Textbook page number. So what is abstraction? Abstraction is used to hide background details or any unnecessary implementation about the data so that users only see the required information. It's another name we can say abstraction is abstract, we can say. Generally, we are writing the small brief note about your project or your what you are going to do in developing a design. So about your design or project, you are writing in a brief in 1 page, 2 pages, in a brief manner, 2 or 3 paragraph like that. So that is called abstraction. That's why we are telling we are hiding unnecessary details, only we are giving the required information on a piece of paper or to anyone. So that is called abstraction. The interface of a component should be independent of its implementation. A component could be a hardware or software component. So interface of component should be independent of its implementation. Means we are not giving the detailed information about how we are implementing. Just we are giving the brief information about your component. The component may be a hardware or software. The first step in abstraction is to break the problem into as many different functional parts, sub-problems, or meaningful units as possible. Here it means we are writing about your problem in different functional parts. Means we are not giving a detailed paragraph or detailed view. Just we are dividing that problem into small parts and we are writing there. First I will do like this, the problem is this, and I will implement like this, not giving the detailed information, just brief information. The abstraction is a technique adopted by artists from historical times to bring out the best principles of the subject. Abstraction is the process of taking away or removing characteristic from something in order to reduce it to a set of essential characteristics. Here, historical background means from historical times to bring out the best principles of subjects, means like a landscape or sunset or anything from example I'm telling. So we have to take out the best output from the problem. Now abstraction is a process of taking away or removing, means we are removing unnecessary things. We are just concentrating on its characteristics to reduce its burden. So we are writing the essential characteristics on a piece of paper. So that is called abstraction. Abstraction provides us with a view of building blocks that can be used to develop a set of design solutions. So we are writing down the abstract of the problem in a blocks, like set of problems also we can say, functional parts also we can say. So we are writing in a small blocks way, means small paragraphs, small sentences also we can say. Last point, generate as many different alternative designs as possible in order to maximize the likelihood that we will develop the best solution to the problems. Means we have to write down the different alternative designs which is possible to get the better solution for a given problem. So this is about the abstraction. Now going to the next topic, it's called modeling. So the second topic in our chapter is, and last topic, modeling. Modeling means we are creating some model of your problem which shows the solution in that model. And it is not the actual implementation and it's not the actual object or the project solution. It is look like similar to that one, which may have the same features, may have the same functionalities, but it is not the actual object. So let's see. So models allow us to organize data, structure our thoughts, describe relationship, and analyze proposed design. So these allows us to organize the data, different data, what we are utilizing. Structure our thoughts means step by step steps what we are implementing. Describe relationship means what is the relationship between variables, how it look likes, and analyze the proposed designs. An engineer may often be tackled with problems that are unfamiliar. Either the problem has never been solved before by anyone, or at the very least, it has never been solved by this particular individual. So, engineer may often be tackled with the problems that are unfamiliar. It means a new problem should be solved by an engineer. It means which may not be solved by other person, individual, or by himself itself. Models can help us recognize what we know and what we do not know about a problem and its solution. So, once you create a small model of your actual problem, actual solution, you can say, then we can see and we can analyze by seeing that what exactly to be do, exactly what it is not completed, so that we can improve the solution. Model building and testing is a skill that should be mastered by every engineer. So engineering skill is model building also and testing also. So that before implementation, he must know how to build a model about your problem and how to test it. Creating a model whenever we design a system or process that is too complex, too large, or insufficiently understood to implement without further evaluation. Means without further testing or without further implementation, we must create a model. Maybe it may be a system or process which may be too complex or too large, and it may have insufficiently understood by implementation. So let's see what are the models. Working scaled or maybe concrete miniature used to test engineering solution. A model can be a working scaled concrete miniature means it is look like same thing, but it is a small one, but it should be a working one means we can understand by seeing that one. If you move that one, it should move. If you see the parts in it, it should be exactly similar to the actual solution. An abstract set of equation describing the relationship among the system variables. So the first one model can be a working scale. The second one may be a set of equations. Means we can, if we cannot create a working model, then you can have a equations to resemble or to show that it relates to the model. Means we have to write the equations. If something is changed, it has to be varied and it can give the some outputs. Computerized simulation and animation of a process also can be a model. Two-dimensional or three-dimensional graphical description of a design also can be a model. Any other purposeful representation of a process, object, or system, it can be a model. So these are the different models we can create as per our engineering solution. So no need that all should be created. Any one of it or many of it also we can create. So what are the modeling formats and types? We have two methods of modeling. That is, we can have a format or we can have a type. So first we study about the types and then we'll go to the formats. What are the types? Models are sometimes divided into three types: iconic, symbolic, and analogic. So iconic models. Iconic models are visually equivalent but incomplete. Means we can see again, we can understand what exactly it is, but it is not the actual. Means it is not the actual solution. It may be a two-dimensional, 2D, or three-dimensional, 3D representation such as maps and world globes. Means we have a maps drawing on a piece of paper or on a computer, or a world globe on a simulation way, which are not actual one. Means world globe means it's not the world showing resembling the actual, but it is a part of it. We can understand many things from it, where exactly what it is there, that one. Now 3D physical model of proposed bridges or some buildings also, we can say 3D physical models like Burj Khalifa or some your big monuments you are creating and you are keeping on a table, and it resembles the same thing, same what it look likes. Or highways or buildings, you can say 3D physical models propose bridges, highways, buildings, and 3D models generated via CAD, computer aided design. Means if you are not able to create models or concrete models, you can create in a computer aided design, like a 3D Max you can use. So these are not actual one, but we can show the shape, size, and appearance from these iconic models. These are iconic models. Now coming to this analogic. Analogic models are functionally equivalent but incomplete representation. They behave like the physical process or system being modeled, even though they may or may not physically resemble the reality. Means analogic models are functionally equivalent but incomplete representation. Means here, it previous case iconic, they are not working models. Means they are only what we call concrete or 2D 3D models, which look like the same, but we cannot test on it. But analogic models functionally equivalent means we can test on it, but they are not the big scale or actual scaled model, actual scaled solution, like a aeroplane. If you are creating an aeroplane and you are testing in general way, in the general wind pressure or general way, other implementation if you are doing, it may be cost more or it may have so many problems to face. But if you create a aeroplane with the same functionality in a small scale, that is miniature airplane we can say, and you want to test on it, then it will be easy to get the results, outputs we can say, and characteristics we can take out. So how to test that one? The aeroplane, that aeroplane can be tested in a wind tunnel, means small tunnel we can be created, and we can test in that, so that the results we can achieve, its characteristics, its outputs can be achieved. So they behave like the physical process or system being modeled, even though they may or may not physically resemble the reality. Example of analogic models are miniature airplanes dynamically tested in wind tunnels. So these airplanes are not the actual one, but it look like same. It works like same. It is a small scale model of your actual airplane. Electrical circuit diagram. So we can draw the electrical circuit diagrams in a computer by using some softwares, and we can test on it by changing the voltage, current, many variables we can change in it. Components value we can change it, and we can check the outputs, waveforms you can check it. So that is analogic models. Computerized simulation of manufacturing process means we are developing a simulation of a manufacturing process, how the steps involved and what are the feedbacks and how it will look like, and what are the how much time it is to be taken to complete the process. So these are the analogic model. Now coming to the last one in types, it's symbolic. Symbolic by name itself, we are telling symbols. These are highly higher level abstractions of reality, such as equations. F is equal to ma, force is equal to mass into acceleration, or area of circle pi r square, like this. So F is equal to ma, force into mass, F is equal to ma, force equal to mass into acceleration, or area of circle pi r square. So these are some examples of symbolic models. Means here we are not creating the actual solution, we are not creating an object, just we are analyzing its equivalence in symbolic way. Means we are writing its equations. Like these models include the most important aspects of the process or system under consideration in symbolic form, neglecting all irrelevant details. We are neglecting its appearance, its behavior. Just we are writing the relation between variables, we can say. The symbols can then be manipulated and quantified as necessary to increase one's understanding of the physical reality. Mathematical models, that is, set of equations, can be used to describe and predict the behavior of systems such as a set of masses, springs, and dampers used to represent a human being. Means masses. We want to represent about the human being, how it look like, how he will behave, how he get affected based upon its masses. Means writing equations about human in terms of masses, means weight. Springs means its flexibility. Dampers means its observations, we can say. So these are different ways to represent a human being about his behavior pattern. The orbital behavior of a planet and its moons, means we are writing equation about the planet and about its moon's behavior in terms of equations, and it will show the paths and distance, gravity, and everything it will show in the equations. We are not exactly testing directly there, and we are not showing in reality. Yes, we are writing the equations and we are representing it. Two interacting populations, means here like two interacting populations, means one animal is there which eats the another animal. Then how it will behave, how much time it will take to extinct, then what are the precautions we have to take. So we are writing in terms of equations. Reaction between chemical compounds, in chemically also we can have equations, how the acids behave, how the different chemical compounds behave, its characteristics we'll write in a piece of paper, or we'll do on a computer. A traffic control flow process, means you no need to go physically test in actual scenario of how the traffic is affected. Traffic jams are going to take place, and how fast we have to control the traffic. Just we can have a computer simulation, or we can write equations when the traffic is high or low, how to relate the different ways on a highway or roads in a streets. So we can write a traffic control flow process. So these are the three modeling for types: symbolic, iconic, and analogic. So next we will study about the formats. Modeling formats. Formats. Models are sometimes divided into three formats: sketching, orthographic drawing, point by point projection, or functional graphs and charts. So the three are sketching, orthographic drawing, or functional graphs or charts. So these are the three formats we are discussing in our engineering design. There are many formats are there, but these are three popular ones. So we'll study one by one: sketching and orthographic drawing and functional graph and charts. Sketching. Sketching are used to describe the shape, size, and principal features of physical objects. Sketching also defined a freehand drawing without actual dimensions, without any using the scale or protractor or compass, like this, like a portrait drawing or any drawing which is not having a physical dimensions. Just shape, size will be there, appearance will be there. Visual depictions allow on to work with others in developing ideas quickly during brainstorming session and throughout the design process. So it is a fastest visual drawing, we can say, fastest way of drawing, and which will give you the description, or which will tell about your problem solution in pictorial form, we can say, picture form. So engineering sketches do not need to be exactly accurate or detailed. So I told you it doesn't need any uh, dimensions, exact dimensions, or exact behavior. So their purpose is to illustrate the significant elements of the design, just elements of design, how it look like and how it appears. That's it. And some detailed explanatory notes. We can have some notes on it, some design picture and some notes it should have. This which will avoid the misinterpretation, interpretation and confusion. Means a small picture shows your about your shape, size, and physical appearance, we can say. And by seeing that, we can have some new ideas and alternative designs. We can develop in fastest manner. That is sketching. Now coming to the second one, modeling format, that is orthographic drawing, also known as point by point projections. If you have given a 3D uh, object, you have to show its projections in 2D format. Maybe it's top view, side view, front view, back view, bottom view, like that. So the definition is orthographic or multi-view drawings are particularly useful in describing a three-dimensional object in sufficient detail to allow fabrication and manufacturing to commence. If you create a 3D object by using, let us take model also by using AutoCAD, and if you want to give this to manufacturing or fabricating, they will be having some confusion about its size, shape, and its depth and width. But if you give the same 3D model in types of 2D views, maybe top view, side view, etc., then it will be easy to analyze and what is the shape, size for fabrication and manufacturing. So that's why we use orthographic drawing. There are two ways to place the different views on the drawings. First angle projection, that is also called as European standard, which follows ISO drawing. That is, it is a ISO drawing standard, also called first angle projection, is used in Europe. Consider a projection on the opposite direction generally. The top view is under the front view, the right side view is at the left of the front view, like X-ray. Already this you studied in your drawing class in the lab. The another way of projection is third angle projection, American standard, also called third angle system, used in USA, America. It is the ANSI drawing, American National Standard Institute. ANSI places the left side view on the left hand and the top view on the top, like a photographic image. See the example here. So both compared, I compared the both ANSI and ISO. The left one is ANSI, the third angle projection we call Europe American standard. The right side one is ISO. It is a first angle projection, you can say. So the you can see exactly the top view of this 3D is above the front view, and the right side view is on the right, and left is on the left side, and back is here, and bottom is on the bottom of the front view. Same look like exact, that is like photographic image, but in the first angle projection ISO standard, it is slightly different. The bottom view is above the front view, the top view is below the front view, right side is on the left, left side is on the left view is on the right, vice versa. So this is the difference. Based upon the usage, you can use any one of it. Nothing in it, just we have to know which view you are using, that's it. Example, I'm showing orthographic drawing, how to draw the views. So let us take, this is the 3D object. Now we are keeping in a uh, imaginary glass box. Let us take with a walls of imaginary glass box. Then you can have some numbers of these points 1, 2, 3, 4, 5, 6, and how it will projected for the front view, for the side view, and for the top view. Let's see. Now open that box and see that its projections. So these are the front view, this is top view, and this is the side view. Now see, this is the actual object, and these are the projections. This is top, front, and right side views. Like this, we will draw the orthographic projection. Now the AutoCAD 2D modeling. Generally, there are three projection, three types of coordinates: absolute, relative, and polar. About this, I have separate lecture, video lecture, and I uploaded as a part 2 for chapter 3, modeling and abstraction. So you can refer that one, which is a problematic question, very important. So that's why I separated from this three part. So it's a practical part. You can view the video. You can see the video. So next, go to the another third type of modeling. Last type, there is functional graphs and charts. Charts allow one to clarify and analyze data that might be misinterpreted if presented only in numerical or textual formats. The challenge is to select the most effective diagrammatical format for meeting the needs of an audience. So, showing the what we call data in texture format means writing on a paper and showing the variations of it, showing the analysis of it in a paragraph manner. Yeah, then it will be not easy to understand to by everyone. If we are showing in a graphical way, then it will be easy to understand. Functional graphs describes relationships between two or more variables, often based upon the empirical or experimental data. In two-dimensional graphs, the independent variable x is usually represented by the horizontal axis, also known as abscissa, and while the dependent variable y is denoted by the vertical axis. How it look like, so you can check. Line or curve charts often are used to show or estimate continuous variations or trends in one or more numerical entities during specific time intervals. During the some specific time intervals, we are showing the curve to interpolate variations between intervals and to extrapolate trends into the future. See the but during the duration from on x-axis we have year, on y-axis we have number of units sold multiplied by 100,000. So during the intervals from 1998 to 1999, how much is sold? The point is coming, and from 1999 to 2000, and so on. So after the putting the points, how much it's sold, we can have a curve, linear or exponential. The curve will come, and based upon the curve, we can derive an equation how the curve is there, how the variation is coming. If you write this in a text in a paragraph manner, you cannot understand easily. If it is in a curve manner, we can easily say, okay, this is an exponential manner. Improvement is there, or every year it is increasing, or every year some dip is there, decreasing there. What's the reasons? So we can analyze easily. So that's why I use this type of modeling. Like this, another example here: functional graph of linear relationship between two variables x and y. So this is a linear one, and we can have some slope of it, and we can have some equations of it, so that we can have another, by this another model also we can develop, symbolic model also we can analyze. Another graph, column or bar charts are used to present and compare discrete variations in quantities of interest. They sometimes are shown in three dimensions for greater visual impact. Horizontal bar charts are preferred to vertical column charts when data sets differ greatly in size. See, these are two bar charts are I'm showing, column charts and bar charts. So horizontal bar charts is not that much effective compared to the column chart, three-dimensional column chart, not the two-dimensional. The three-dimensional the column charts have more advantages than the horizontal bar charts or column charts. So these are the some examples what we have, like traffic facilities during 10 years interval we can show in a graph, vertical column chart, and you can show the uh, pie chart also, how many different items are there, like soccer, basketball, football, bicycles in a pie chart. So this is about our formats and abstraction.